I'm very happy to be a part of this important town hall webinar today. And thank you everyone for joining us today. About the Alliance. Well, the Manufacturing Safety Alliance of BC is a not-for-profit health and safety association supporting BC manufacturers and food processors. We provide BC's manufacturers with education, resources, and training on workplace health and safety, online, on-site, and in open learning classes around the province. Alliance Health and Safety experts offer confidential support and answers to your health and safety questions. We wanted to thank you for joining us for a moment of silence today before we began this presentation. Today across Canada, we observe the National Day of Mourning. Please take a moment after the presentation to view the video for this year's Day of Mourning that you can find at www.dayofmourning.bc.ca. Today, our presenter will be sharing important information and resources to help us understand respiratory protection requirements and options for infectious diseases such as COVID-19 and other airborne hazards in the manufacturing and food processing sector. Jasmine Calzi is a safety advisor and occupational hygiene specialist at the Manufacturing Safety Alliance of BC. For nearly 3 years with the Alliance, Jasmine has assisted clients with concerns relating to air quality, noise exposures, and exposure control plans. Her experiences include assessing risks and exposure to crystalline silica, welding fumes, and volatile organic compounds, as well as working with clients on toxic process gases such as ammonia. Jasmine holds a Master of Science in Occupational and Environmental Hygiene degree from the University of British Columbia and a Bachelor of Science in Chemistry from Simon Fraser University. Welcome, Jasmine.
Thanks, Rosa. I would like to thank everyone for taking the time to attend this webinar. The COVID-19 pandemic has opened our eyes to consequences of uncontrolled virus spread. As employers who have workers in essential services, it's our responsibility to protect workers appropriately under our supervision. I've put this presentation together to assist our clients in understanding respiratory protection. Right now, as you may have encountered, there's an abundance of information actually out there on this topic. And we're getting so many questions where the answers need a minimum background of knowledge and theory. My intent for this webinar is to help you understand the basics of respiratory protection. We want to understand the terms we so casually use in our talks and give a better understanding of those phrases. We want you to make educated decisions, knowing what to do with this information when it's presented to you, so you can make these calls when determining what respiratory protection is good for your workforce. Also in this webinar, we'll go over what other options you have in terms of respiratory protection and see what other protection may work in place of the N95. So let's get started. As we all know, respirators are protective devices which cover the worker's nose and mouth. They can even cover the entire face and head to keep airborne contaminants out of the respiratory system, because that's the end goal. Respirators can also be used to protect against gas and vapor contaminants. These devices can also be used to protect against particulate contaminants, such as dust, fibers, mists, fumes, and even biological contaminants. This includes viruses and molds. Biological airborne particles share the same physical characteristics in the air or on the surfaces as inorganic particles like dust. So that said, the purpose of this webinar, in context of COVID-19, we will be focusing on respiratory protection, which protects against particulate contaminants. As you may know, there are a variety of different types of respirators on the market. For example, these can be disposable particulate respirators. We sometimes casually call them dust masks. This would be this one in the center of the slide. Or you can also have reusable elastomeric respirators, which are seen in the very left and right of the slide. Choosing the correct respirator, having the correct particulate filter is essential. in ensuring adequate protection. But to do that, we first need to have a good understanding of the terms we casually use in our conversations. In our current situation, for the protection against biological agents, we automatically defer to the N95. It's one of the big buzzwords we are hearing again and again. And for the most part, everyone is scrambling to get a hold of them for their worksite. So when I'm speaking with my clients, one of the first questions to them is, do you know what type of protection you're asking for? I'd also ask if they know what protection the N95 provides. And majority of the time, my clients can't answer this question for me. So let's get an understanding of the basics to see what these numbers and letters mean. For particulate filters, there are two aspects we need to understand, these being particulate filter classes and particulate filter levels. We will start with particulate filter classes. There are three types of classes which are recognized, and these are the N, R, and P. These are classified based on their ability to filter against oil particulates, as oil pretty much degrades and reduces the filtering efficiency of the filter material. The N filter class means it may be used in any atmospheres where there's no oil particulate. The R filter class means it may be used in any atmospheres where there's no oil particulate or up to one shift where there's oil particulate present. And lastly, the P filter class means it may be used in any atmospheres, including where there's oil particulate, for more than one shift. The N, R, and P classes, in simple terms, describe how it will filter, based on the oil content of the particulates. And that's pretty much it for filter classes. A quick way to remember this is N stands for not oil proof, R is oil resistant, and P can be oil proof. Next, let's look at particulate filter levels. These levels are classified on their ability to filter out particulate, which are 0.3 micrometers in diameter. So to give you an idea of what this means, the human hair is about 50 micrometers in diameter. So 0.3 micrometers is quite small in size. It's these type of particulates which are so small in size we should be concerned about, as they are able to enter deep into our lungs. So here in this table, we have three classes: the 99, the 95, and the 100. The 95 is 95% efficient in removing particulates 0.3 micrometers in diameter. The 99 is 99% efficient in removing 0.3 micrometers in diameter, and the 100 is 99.97 efficient. And that's pretty much it for particulate filter levels. Now, when we combine the particulate filter class with the particulate filter levels, we get our designations that we commonly see on disposable respirators. And we also see this on some other filters and cartridges. The 9 classes here are considered NIOSH approved. And I will speak on what NIOSH means a bit later in this webinar. But for the purpose of this slide, look at these classes. These designations would be the ones we commonly see in British Columbia. I should also add that not all manufacturers manufacture all 9 of these particulate filters. More generally, the N95 and the P100 are the most common. Many manufacturers don't really make the 99% series of the filter levels or the R series of filter classes. So let's go back to our question, which was initially posed. If you were issued or received an N95 respirator, what does it mean? Knowing what we know now, the N95 particulate filter on this respirator is not resistant to oil particulate and is 95% efficient at filtering particles which are 0.3 micrometers in diameter. The same concept applies to the P100. The P100 particulate filter is strongly resistant to oil particulate and is 99.9% efficient in filtering particulates which are 0.3 micrometers in diameter. So now you know how to interpret these designations commonly found on particulate filters. So let's go over a side note now and bring into perspective how COVID-19 compares to these filters. As I mentioned before, generally, biological airborne particles share the same physical characteristics in the air as inorganic particles like dust. Pretty much, they move the same. The COVID-19 virus is about 0.12 micrometers in diameter. But from what we've discussed, the N95 particulate respirators filter at 95% efficiency for particulates 0.3 micrometers in size. So the question might come into your head, 0.3 micrometers is larger than 0.12, so does this even filter? The thing we need to consider is how the virus is transmitted. From Health Canada, COVID-19 can be transmitted via respiratory droplets, right? So when these droplets leave someone's respiratory tract, whether it be by coughing or sneezing, these droplets can contain the virus. And these droplets are much greater in size, greater than the 0.12 micrometers. So when you see these respirators being worn by others, it's for the prevention of these droplets entering the mouth and nose. Droplets can also range up to 400 micrometers in size. But this also highlights the fact respirators do not give 100% protection from COVID-19 or any other biological agents. It's not the perfect solution, and other controls should be considered, such as engineering and administrative controls. So it's something to consider when choosing respiratory protection for your workforce. Let's move on with the webinar. So we talked about particulate filters, which are made up of fibrous materials. But what about chemical cartridges? Can cartridges protect against dust? Would they protect against biological agents? And the answer to this question would be, it depends on the type of cartridge you have. Chemical cartridges can be used with half or full face respirators. These cartridges contain activated carbon, which can be sourced from charcoal or even coconut shells, for example. They are designed to protect against certain chemical gases and vapors, but they can also be used to protect against particulate contaminants. And this can be done by adding particulate filters onto the cartridge. Depending on the cartridge being used, you can get adapted pieces for it. This is typically available, and you can always contact your supplier for more information. So it starts off with a plastic cover, under which a particulate filter is placed, and then capped on to the cartridge itself. Or you can use dual cartridges. Dual cartridges or combination cartridges are those types of cartridges which can filter both particulate and specific gases and vapors. For these, you don't have to add another filter or cap or anything like that. You would use as is from the manufacturer, but with no further assembly would be required here. So the next thought would be, how can I check to see if I have the right one? You can start off by reading the manufacturer's instructions. In that document, it should specify if your chemical cartridge has a particulate filter or not. Another option, and a much quicker route, would be to read the label. The label should specify any of the 9 classes we discussed earlier. We want to look for the labels that say, for example, P95 or N95, N100 or P100. Any of these mean it's a particulate filter. You may also come across other abbreviations when you're reading the label of your chemical cartridge. So to give you an idea what these letterings may be, just keep in mind that OV is organic vapor, Cl is chlorine, AM is ammonia, HC is hydrogen chloride, FM is formaldehyde, SD is sulfur dioxide. Anything that says OV/P100, it's a combination. So it's organic vapors, and it's a particulate filter rated at P100. OV/P95 means it's an organic vapor cartridge, and it also has a particulate filter rated at the P95 level. Just note, only those chemicals which are listed on the cartridge are the ones which the cartridge may filter against. As an ammonia cartridge will not protect against formaldehyde, for example. So in the next couple of slides, we'll just go over some examples. In this case, we have a chemical cartridge. Our questions would be, can I use this against particulate matter? So we would read the label around the cartridge. It's usually this label is a colored strip. In this case, it's black. So here it's a OV/P100. So what does this mean? It's an organic vapor cartridge with a P100 filter. So to answer the question, the answer would be yes, it will filter particulates. Next one, we come across a pair of cartridges like this. Would this be considered as a particulate filter as well? Again, we would read the label. Notice it says OV only. So it's good against organic vapors, but not against particulates. So if it's missing any of the designations we discussed earlier, like the 9 classes, it will not protect against any particulates. For these ones, you may use them on your worksite. They're fairly common. Sometimes we refer to them as pancake filters, but just because they're flat. When reading the filter, you can see the designation written right on there. The left one is a P95 and the right one is a P100. For these filters, these are only classified as particulate filters, and these are not designed to protect against any gases or vapors, like ammonia, for example. So now that we've covered the core basics on respiratory protection and some key terms, now we'll go over some things you should also keep in mind. In British Columbia, the Occupational Health and Safety Regulations, Part 8, Section 8.33, respirators which meet the requirements of a standard acceptable to WorkSafe BC may be used for protection against airborne contaminants in the workplace. So what NIOSH is, it's the National Institute for Occupational Safety and Health, and they are a US agency which approves respirators as a whole. So they approve the mask itself, the filters, and even the cartridges. The filter classes and levels, which we discussed, the 9 classes, those are the standards of NIOSH. And the thing to note is WorkSafe BC accepts the standards of NIOSH for respiratory protection. So the N95 mask is an approved filter by NIOSH by their own standards. So it's always a good idea to check the manufacturer's instructions and check the label and ensure the respiratory protection that you are providing or even using is NIOSH approved. But with this said, however, there are situations where WorkSafe BC accepts respirators from other jurisdictions. So take a look into this table. This table here summarizes acceptable alternatives to the NIOSH particulate respirator, the N95. The alternative particulate filtering facepiece respirators listed here are considered acceptable by WorkSafe BC for protection against airborne particulates like biological agents, where a risk assessment deems a N95 is appropriate. This information can also be found under Section 8.33, subsection 2 of the guidelines to the BC Occupational Health and Safety Regulations. So in context to COVID-19 and this pandemic, if you are the employer or you are a worker who works at a company which is trying to get a hold of masks like the N95, these listed are considered as equivalent alternatives and may be more available than the N95. Because right now, there's a narrow focus on the N95 only, because that's the only one we know of. It's more common. For example, the FFP2 and the FFP3 particulate respirators, these are the ones that come from Europe. These can be used as an alternative to the N95 only. But again, just keep in mind what the N95 is good for. These respirators listed in this table are only equivalents. And if you're already considering these alternatives, I would suggest to ensure that the products being ordered are real and not counterfeit. So ensure that the performance standards are referenced on the products you're buying and to do your own research as well. So a note on respiratory protection. Remember how I said human hair is about 50 micrometers in diameter? And respirators are tested for efficiency against particles, which are 0.3 micrometers in diameter. So this helps us understand why having facial hair while wearing a tight-fitting respirator is not a good idea. Hair diameter is bigger than the particulates we worry about. So always ensure there is no hair between the face seal and your face to ensure a tight fit. This visual here gives a good idea on acceptable facial hairstyles. As long as the hair fits within the respirator, and not anywhere along the seal, it should be good. This graphic gives a good example of the various beard styles acceptable and not acceptable. Another note, NIOSH-approved particulate respirators have a manufacturer's designated shelf life. Dates can vary on numerous factors, such as the type of respirator and filter. In times when supplies may be critical, employers can potentially use expired NIOSH particulate respirators. But there are some conditions which first be met, and these are specified under the BC Occupational Health and Safety Guidelines, section 8.33, subsection 2.1. First of all, they can be used in emergency situations as a last resort only, and also with the following conditions: them being used and stored as per the manufacturer's instructions. Workers must also be informed on their use and know how to carry out the inspection of their respirator. They should know how to check for any degradation or anything that can affect the fit and seal of their respirators. And lastly, workers need to be fit tested. In the following slides, I'll go over some key points to keep in mind for respiratory protection. And we'll start off with fit testing. Fit testing is a regulatory requirement. It's found under the BC Occupational Health and Safety Regulations, Part 8, Section 8.40. When using any tight-fitting respirator, the employer must ensure workers are fitted against the make, model, and size of the respirator at least once a year. There are also other scenarios as well, which may warrant a fit test. So fit testing has to be done, for example, for the disposable N95s, as well as the reusable half-face and full-face respirators. Procedures for fit testing must follow the CSA standard Z94.4-02. I should add the standard is currently available for a no-fee access on the CSA website just because of the COVID-19 pandemic. Usually we would have to buy, but if you're curious to see, I definitely recommend that you check it out. So the point of fit testing is to ensure how well the respirator fits the face of the user, because it's not always a one-size-fits-all. There are two styles of fit testing. One being qualitative, where the worker is subjected to a bitter aerosol or even an irritant smoke, for example. And they would be required to use their senses to see if they can or cannot taste, smell, or even react to it. And the other method is a quantitative fit test. For this, specialized equipment is used to determine the concentration of an aerosol inside versus outside the mask. The one in the picture you see in the slide is a qualitative fit test. User seal checks are another key point to remember. These are important to carry out to ensure your respirator is fitting correctly and there is no leak in the seal. You should always follow the manufacturer's instruction in performing a user seal check. Generally, respirators have two types of user seal checks, these being negative and positive pressure. These checks must be done each time you don your respirator. And this applies to your half-face, full-face, and disposable N95s. So in your workplace, if tight-fitting respirators are issued, ensure workers are trained on how to perform these seal checks. Though I won't be going over these steps in this webinar, but as a takeaway for those attending, we will have posters and videos for your reference in showing you these steps on how to perform seal checks on disposable respirators as well as reusable respirators. Training and education also play a vital role for respiratory protection. Ensure your workers are trained on how to correctly don and doff their respirators. And also ensure they know how to inspect their respirators, so defects or missing parts can be identified and corrected. It's also a good idea to have a respiratory protection program. A respiratory protection program consists of a statement of purpose and responsibilities, written procedures for the selection, use, inspection, cleaning, maintenance, and storage of respirators, instruction and training of your workers, medical assessment of the respirator wearers if it's required, any related documentation, and a program review. This program itself, it is a formal document, and I won't be going into it in detail in this webinar, but there is a lot of information related to it. And I'll reference a resource at the end of this webinar, which you can refer to develop yours. It's also a good idea to go over the limitations of the respirators with your workers. So there's no false sense of security in wearing one. All respirators are rated to protect up to a certain concentration, and they may or may not work for every type of environment. For example, respirators will not help you, for example, like the N95 won't help you in an oxygen deficient area. Always refer to the manufacturer's instructions to determine service life of cartridges and filters, and any other applicable limitations to the respirators. And lastly, carry out a site-specific risk assessment to see what type of respiratory protection is appropriate for your workforce to ensure the correct protection is being provided. Respirators are considered as personal protective equipment and therefore are considered the last line of defense. Always consider other control methods such as engineering and administrative controls first to solve the problem. And if not, then using a combination of controls would be the next best bet. And that concludes my presentation on respiratory protection basics. In order to support you further, we would like to provide you with some resources. So we at the Alliance have made resources such as posters and short 1-minute videos on donning and doffing disposable and reusable respirators, performing seal checks on these types of respirators as well. They will be available to be downloaded from our website, or they can also be requested from your safety advisor. And we will also be giving these as a takeaway for those in attendance later on in this week. A recording of this webinar will also be soon available and will be communicated when ready. So feel free to contact us on our support line. In addition, I also suggest referring to the WorkSafe BC guidebook on Breathe Safer. It has good content and it goes over in detail of the requirement of a respiratory protection program. This document itself can be directly downloaded on WorkSafe BC's website. So that's pretty much it for my presentation, and I'll pass it back to Rosa to end it off.
Thank you so much, Jasmine. It was quite informative and very thorough. Let's take a look at the questions that we have coming in. So the first question that we have is, for P filters, what do you mean by for more than one shift?
So the P filters, they can be used. So I'm not referring to the disposable respirators because those are limited to like a one shift. The P filters are ones that can be used over multiple shifts when you have like filters on the cartridge itself, whereas the R series is limited to only one shift if there is oil particulate, because they're more strongly resistant to oil particulate, so they can be used for a longer period of time. But it only refers to the filters whereas attachments to the half face or the full face respirators.
Okay, thank you. We have a related question. Can you please give us an example of an oil particulate?
So, for example, if there is grinding operations taking place and there's some type of oil coating on the piece of material you are grinding, so that type of particulate can be considered as oil particulate. Or if there's lubricant in there, or if there are any other operations happening nearby where there's some type of oil particulate in the air that can contaminate the dust, for example, you're trying to protect against, that would also be considered oil particulate. So you have to assess the operations actually taking place and take into account the surrounding environment as well, and see if they can contaminate the particulate you're trying to protect yourself against.
Okay, thank you. Our next question is around aerosols. Are aerosols considered particulates or gas vapor?
They would more be classified as gases, vapors. Again, it depends because we sometimes casually use aerosols when you're trying to describe particulates as well. So we would need a little bit more context for it. Aerosols are something that we can, again, it depends on the context itself because we casually use it in conversation, but generally they would be considered as like a gas or vapor generated from that actually.
Okay, thanks. Let's take a look at our next question. Can you please explain further the free fit testing portion of your presentation and how to obtain this free testing, fit testing?
Okay, so fit testing itself, so to do fit testing, you can do this internally or externally. So I'm gonna actually go back on my slide so then we can just go over that. So when I said free, I was actually referring to the actual CSA standard. So the CSA standard is Z94.4-02. This document actually specifies how to perform the fit test. It's currently for free on their website. You can't download it, but you can view it. But to carry out fit testing itself, the requirement is for it to be done as per that standard listed in there, in that document. So if you can, but in terms of it being free, usually people either contracted it out, someone would come on site and carry out the fit testing for your workers, or you can do it internally in-house, ensuring you follow the CSA standard. And either you can send someone off for training for this, or it could be like someone like a train the trainer if someone is knowledgeable of the standard itself and follows those procedures.
All right, and another question related to that, does a person have to be certified in order to conduct a fit test? So is there some sort of certification as well for this?
So technically, if I'm only referring to WorkSafe BC regulations, it doesn't say anywhere you have to have a certificate to carry out a fit test. All it says is you follow the standards, the procedures written out in the CSA standard. That said, if you want some type of formal training, I know 3M does have these half-day sessions on how to do fit testing, and they pick various locations around BC, and they issue a certificate as well. But if I look strictly from the regulations, nowhere in there it says you have to have a certificate.
Okay, thank you. Now we have a question relating to exposure control plans. So the question is an exposure control plan or ECP required for a respiratory protection program?
Okay, so an exposure control plan it's a completely different document from respiratory protection program. So it's like comparing apples and oranges. Exposure control plan is a formal document which you put into place specifying how you are protecting your worker from a specific contaminant. So this can be something that be causing cancer, it can be a sensitizer, it could be a reproductive toxin, something you are going you're going above the exposure limits in BC, you would have an exposure control plan. So that document, it's a formal document, just specifies how you are protecting your worker. You would specify the engineering controls, the administrative controls, as well as PPE. The respiratory protection program is a different document. So this document would specify pretty much all the PPE, all the respirators you have issued on site. And if I go back on the slide where it goes over the components of your program itself, you would specify how do you select, use, inspect, clean, maintain, and store your respirators, and it will cover also instruction and training. So the respiratory protection program is narrow focused on respirators only. You can refer to the respiratory protection program in your ECP, but an exposure control plan for a respiratory protection program, it doesn't work like that. They're two separate documents. Exposure control plan is for protection against contaminants and what you're doing. Respiratory protection program is all about the respirators you are issuing.
Okay, thank you. Our next question is about the P class, I believe. The question is, what does it mean for more than one shift for the P class?
Oh, I think we already asked that question.
Oh, we did?
Yes, at the beginning.
Okay, sorry. Okay.
Yeah.
So how long can a user wear an N95 mask before having to change it? So what's the usual lifespan of the mask?
So N95s, so I'm assuming you're talking about like the disposable. They're called disposables for a reason. Usually they say at the end of the shift, you throw away, right? They're considered as like one-time use. And that's as per manufacturer's instructions. Again, always follow what the manufacturer says, right? Because they're the ones that actually design the masks themselves. So for N95s, after one use, for me, for example, if I were wearing one, I would throw it at the end of the day after I'm done using it.
All right. And we have another question, a very specific one about a user that uses 3M respirators, they say, for graphite. They're asking, how often should we change it? It says it's good for 6 months upon opening, but we seldom use it, probably maybe twice or less in a year.
Okay, so for graphite, that's pretty much, it's a form of carbon, right? Yeah, okay. So again, to get the service life of your filters and cartridges, and if you're using, I believe, Rosa, you said 3M?
Yes, that's
3M?
That's what
Okay.
the question indicated.
Okay, so for 3M, if you go on their website, they actually have it's a cool little feature that they have. You could click on a link where it tells you the service life of their cartridges. So pretty much you write down how much, you could put it in an approximation or assume worst case, what the concentration you were being exposed to or that respirator is being exposed to, and it calculates a service life. It tells you, okay, after X number of hours, you are supposed to replace this filter for that. Again, in terms of, it's hard for me to tell you like after how long. If it's strictly just a particulate filter, there are some manufacturers that say after 40 hours you throw away. There are some manufacturers that say if once it becomes difficult breathing through it, you would switch. So it depends. But I would highly suggest you go on 3M's website and look up the service life tool they have and put in all the details. Say you're protecting against graphite, you're doing this for this many hours. This is the expected concentration of exposure. Just assume worst case if you don't know, and then it spits out a number for you. And then you can always work your way from that. It's a document you can print, so it's also a good idea to keep on hand if you were ever to get questioned on it.
Okay, thank you. On to our next question. We have one of our participants saying that they are a qualitative fit test provider. How can they fit test workers during a respiratory pandemic when the fit testing procedures require heavy breathing with and without a respirator?
So something like that. So this, again, I say factor in your risk assessment, right? And see what other type of controls would be possible for it. Can you further protect your worker or yourself? Because for like the qualitative side, yes, I agree, we have to be in close contact. But can we use like possibly face shields? Can we have wearing the mask? It's like the fit tester themselves wearing a mask. Is there any other way to, just looking into risk assessment, any other way you can create some type of distance for it? Otherwise, if that's not possible, you might have to defer to a quantitative fit test, because in that one, since the specialized piece of equipment does all the testing for you, you can keep a considerable amount of distance between yourself and the machine, as well as the user being fit tested. So that can be another option as well.
All right, thank you for that. Another question of ours is referring to the regulation. They ask, with respect to the Occupational Health and Safety Regulation, Section 8.43, for optional use, there's no reference to fit testing needed if an employer chooses to provide a respirator when Section 8.32 does not apply. They are asking if they're interpreting this correctly.
Yes, you are. So for optional use, if it's not mandated by the employer to wear respirators on site, but an employee still chooses to wear a like a respirator, then yes, fit testing for that is not required. But the employer does have other responsibilities, and I don't know them off the top of my head, but from the ones I do remember, I believe you have to provide a respirator that is adequate for the protection, and I believe there is some sort of training involved with it as well. Within that section, like optional use, the regulation itself refers to other sections within Part 8, which need to be fulfilled by the employer. But yes, fit testing would not be required in that case.
All right, thank you. We have another question asking, I just wanted to confirm that a shift was 8 hours only, and so employees would need to change their N95 respirator if they were working 10 or 12-hour shifts.
So generally, a shift is defined as 8 hours. Again, knowing the critical supplies right now for like the N95s, it might be worth asking the manufacturer to contact them and see what if we go after like a 10 or 12-hour shift, right? Because some manufacturers would say after one use, and a use can be defined as like the full shift, right? So you can, I do recommend you contact the manufacturer and see what works, and then base your decision off that.
Awesome, thank you. One of our next questions is relating to time restrictions. So the question reads, do any time restrictions or maximum number of hours for wearing N95 due to the breathing restrictions any health or respiratory concerns? So I think they're referring to, is there a maximum number of hours that the user should wear the N95?
So they're considered disposable after one use, right? Generally, they'll say like a one shift. So shift will be defined typically as 8 hours. Again, if you need to go more than that, then I would definitely recommend you contact the manufacturer or even your supplier and just ensure that it can be used more than that. But generally, it's 8 hours for the disposable respirators.
All right. There is another question about grinding plastic. So the question reads, we use our N95 masks for grinding plastic regrind. Should employees be changing the mask every day, or can they be used longer? Is there a standard time for usage within resin regrind?
So, so Rosa, did that question say N95?
Yes, they did.
Yes? Okay.
Indicate, yeah.
So again, N95s will only be good for one shift. They are considered disposable, so you wouldn't go back and wear them the next day. For resin regrinds, they would be considered the same as any other particulate. If a N95 is what is being chosen to use to protect against it. So 8-hour shift would be the number. If you need to go longer, we should contact the manufacturer and just get a confirmation on it. Otherwise, for N95s against plastic resins, They should function the same as per any other particulate contaminant, as far as my knowledge goes.
All right, so I think we have time for just one more question. So this question is referring to beards. As you know, many employees have a beard. Are there any engineering solutions to consider to have a mask suitable for this situation?
So for respirators, so engineering solutions, so anything that could remove the need of the respirator, where that the contaminant you are concerned about can reach even like the mouth or nose of the worker of concern, that would be considered engineering control. So you can consider like some type of barriers, ventilation, depending on the contaminant. For example, welding fumes, a lot of people go for like the exhaust arms. So that could take away all the fumes, so then you wouldn't technically need a respirator, but again, every situation is different. In terms of respirators, there are other respirators on the market that I did not talk about in this webinar, as I'm trying to keep it fairly simple. But you can get the ones that are like the hooded ones where air is being supplied. And then in that one, you wouldn't really need to get rid of the beard. You can still keep it, but so it's a different type of respirator. It requires a little bit more in detail, but if you want to just if there's any way, Rose, that we can contact them and I can give them more information separately in the email for that, because that will be fairly a long answer. But I could also give them their options for different respirators.
Yes, maybe perhaps with the contact email that we'll provide in a little bit. Yes, perfect. Awesome. So thank you everyone for your questions. Unfortunately, that's all the time we have this morning. If we haven't answered your question yet, we will get back to you with answers by email or on our COVID-19 FAQ page. If you have any other health and safety questions, please contact our OHS support line at 604-795-9595 or reach out to us through our website anytime. Before we go, you may also be interested in these webinars. Join us this Thursday, April 30th, as our government supports to industry with Labour Minister Harry Bains. And next Tuesday, May 5th, the topic is ergonomics tips for working from home with one of our ergonomists on staff. So thank you very much, everyone, for joining us today. Please take a moment to share your feedback and suggestions in the brief survey in your inbox. Tomorrow, we will send a wrap-up email with a recording of the video and links to the slides and related resources, including these upcoming webinars. Feel free to share these and follow us on social media for more news, resources, and future events. Thank you. The webinar has ended for today.